Hello. So this is a second video in a series on how I integrate surface modeling with bodies. So this video would talk about the surface modeling. In the previous video, I discussed how I utilize solidify groups, and that's my own term, to define surfaces. So I've got two solidify groups here, which means in the end I'm going to have two solidifies. One's going to be a thick and one's going to be a close, and they're going to be solidified into bodies. So I'm going to start off, so this is a coffee mug. So the body, the coffee mug, I've got a solidified group called body, and the handle has a solidified group called handle. I've already got some geometry created. I will open up my body wireframe geometric set, which is nested under the body geometric set, and this is what I call name matching. So body matches body, which matches later a body called body. So I've got some points. It looks like I've got some points I've placed in and a line. So you can see the line. I'm not going to model all this again for you, but I got a line at the bottom. I've got a vertical line up here at the top. Then I use the connect curve tool. I'll open that up for you. Connect curve tool to connect this point to this point, both with tangency, continuity, and just I kept the initial one tension for both of those. So that's a nice tool to use. And then I took the line, and the connect curve, and I joined those together. So I've got one nice curve which I'm going to revolve. So that's the wireframe entity for this. Just if you're wondering about size, that first point is at 0, of course. The second point at the top has a Y value of 44.45 millimeters and a Z height of 101.6 millimeters. So that kind of gives you an idea of the sweep and what the volume potentially could be like later. So within my body solidify group, I've got a body surface. I want to make that my defined working location. This is going to be simple. It's just to revolve around the Z-axis. So I can come up and I can take my on the revolve tool here. So the surfaces toolbar, and behind my extrude where it currently exists is the revolve tool. So the profile and the axis of revolution will be my z-axis on this axis system. And let me back up for a second. One thing I also do with I'm glad I checked this, one thing I also do when my solidify groups is I will have an axis system for every solidify group. So I had the wrong one activated, so I'm glad I checked this. So I need to go ahead and make that the active one. So all the geometry is created off of this axis system. And that allows me to, if I need to move the axis system around, it will move the geometry with it. So if I'm not careful about making sure I have the correct axis system defined, it could cause problems later. So I'm glad I checked that. So I've got my correct axis system rolling here. And so I've got a body surface geometric set as my defined working location. I'm going to go to the revolve tool. I'm going to select the profile. And I'm going to go around the z-axis of my current axis system, and I can select it here, or I can right click and go to z-axis current, and I want to do a 360 revolve, and there we go. So that's all it is to this particular surface. So I'm going to, pretty easy. So next surface, I'm going to hide. So one thing I require my students to do is, in the end, when you solidify, you're going to have only one visible surface under the surfaces geometric set. So I don't allow them to hide this. If they do, they lose points. So if they want to not show the surface, they can hide either this geometric set or the overall geometric set. In this case, I'm just going to hide that geometric set because I want to see here, I want to see this curve, because I'd like to introduce what's happening here with the handle. So I'm going to open up the handle geometric set. You can see I've got a handle, and I'm not going to recreate this whole handle for you, but one thing I wanted to point out was how I did the axis system for this handle. So I created this body geometry first, and then for the axis system, and let me make that the current working location. So for this axis system, you notice when I created it, the origin of the axis system, I defined a point, and that point is an own curve point to the joint. And so it looks like, as it currently stands, it's sitting at a ratio of halfway up the curve. And so what this allows me to do is be able to adjust the axis system up and down slightly by tweaking it to, and all the geometry moves with it, of course, if I had the current axis system activated. So that's how I located this axis system, was making sure that it's tied into this curve correctly. So again, that can be tweaked, but it has the ratio sub option. So there's my axis system. That's the current axis system. By the way, that point for locating here, I place inside this handle reference. So if you see this point here, that represents my handle, the point of my axis system, and that can be modified directly from here too if you wanted to. So now let's look at my wireframe geometry. So I've got a spline and a bunch of points. So the spline, so let's look at some points. So I'll look at the first point here. So I've got a point here, which is a known curve point, and a point up here, which is also a known curve point. Let's see how I define that. So I defined it up from this middle point, point 4, which I showed you just a moment ago. So I've got that distance on a curve coming up. And the reason why I did that is because if I move the point, the handle's going to move with it. So that's what I was trying to accomplish when I did that. And it's the same way. That's the first point. Same way with this point as well. So it's coming from the point defining the axis system. So if I move my axis system around up or down, then the handle moves with it. Also, I defined 4 points. You could do a position sketch here too, but I require my students many times not to use a position sketch just to get them used to working with splines. So I have an ellipse here defined from a spline, but again, it would work with a position sketch well too if you put your position sketch origin right here. So that's going to be the profile of my sweep. That defines my wireframe. So the main thing here I wanted you to pick up out of this is that I can move this handle around and it will shift move the axis system around, I should say, and it will shift this up ever so slightly. See that moving? Hopefully it won't blow up my model. It looks like I do have a point here that I'm passing my spline through. So let's look at this first spline and see what it looks like. So I've got 3 points. Looks like I have a tangency direction. Actually, I've got curvature direction. So it's following the y-axis with curvature continuity. I probably shifted this around when I originally created the model just to get the best ergonomic effect. Because I actually do have this mug thrown into the human builder workbench just to see how it fit around a proper hand, a mannequin hand, I should say. And then it looks like I've got a curvature continuity going around 0.6 and another point to pass through. And I probably added that later or whatever just to get the handle correct. So I probably worked on this quite a while. I'll let you figure out how to do that yourself. I don't want to give away too many secrets, especially if you're one of my students watching. So that's my handle. Surface is easy here once I get this created. And one thing I thought about, because I noticed later I'm going to use it after I create a sweep and then I solidify it, I do a thicken tool to extend this out. I think what I'm going to do, I'm actually going to add to this, is going to be different than what I had planned. It normally doesn't work out very well whenever I decide to change my stuff, but let's do a little extrapolate on this curve. So this is a tool I haven't introduced my students to yet, at least. So maybe I'll throw them a curveball here. So there's an extrapolate tool. And so the boundary is going to be there. And what I would like to extrapolate will be this curve. And I'm going to do it, I want it to come out tangent. So it is coming out tangent, so I'll just do it as length. And I do want to assemble the result, so it's going to change the curve. There's a little bit of an extrapolation. Let's do the other end, see what happens. I like this approach better anyway. So at this point, extrapolate it out, assemble the results. So if you're looking under here, Notice the spline hid, the second extrapolate hid, and this is still there. So what I'm curious about here is how is that going to affect? Yeah, that's still moving, so that's good. That's going to work better for me. This is really the way I like to do it and prefer for my students to do it. So it's going to be a little different than I had planned. You won't see, if you watch the previous video, you won't see that thicken option here. That was causing me issues anyway, so no thicken option. Unless you want to do the thicken option, of course. So I'm going to come back, I'm going to activate my handled surface, and I'm going to throw in a sweep. So this is going to be an explicit sweep with reference surface, and I'm going to CATIA calculate the default mean for the reference surface, and I'm going to grab that as my profile, and this is my guide, and keep this default spine, and there we go, there's my handle. So bring these two back up. There's my surface for my handle and my surface for my mug, two Solidify groups. In the next video I will talk about how I add these to bodies, Solidify, and I'm going to change this to a union trim.